Welcome to catenation. In last 4 parts, we discussed the preparation and properties of alkanes, alkenes, alkynes and aromatic hydrocarbons. Now we will revise entire chapter of hydrocarbons.
First, we will discuss when ethane treated with chlorine in presence of light, we will get A. This A treated with aqueous KOH will get B. When B treated with strong oxidizing agent potassium permanganate, will get C. C treated with sodium hydroxide, we will get D. D treated with 3:1 ratio of sodium hydroxide and calcium oxide, they collectively call it as soda lime, we will get E. When E treated with chlorine in presence of light, we will get F. F treated with sodium in presence of ether, again we will get ethane. We need to find out what is A, B, C, D, E and F. We all are know when ethane treated with chlorine in presence of light, we will get chloroethane, CH3, CH2, Cl. So A is chloroethane. When haloalkane treated with aqueous KOH, we will get alcohol. Chlorine will be replaced by OH, we will get ethanol. So B is ethanol, CH3, CH2, OH. When ethanol treated with KMnO4, it acts as a strong oxidizing agent. It will be oxidized to corresponding acid. What is the corresponding acid? Ethanoic acid, CH3COOH. When ethanoic acid treated with sodium hydroxide, we will get corresponding salt, sodium ethanoate. Molecular formula CH3COONA. Sodium acetate treated with mixture of sodium hydroxide and calcium oxide, they collectively call it as soda lime. What's the name of the reaction? Decarboxylation reaction. We will get methane plus Na2CO3. When methane treated with chlorine in presence of light, we will get chloromethane. Molecular formula CH3Cl. The CH3Cl treated with sodium in presence of ether. Name of the reaction, Woods reaction. Finally, we will get ethane. I will repeat again. When ethane treated with chlorine in presence of light, we will get chloroethane. This reaction is called as photolytic halogenation reaction. This chloroethane treated with aqueous KOH, we will get ethanol. This reaction is called as substitution reaction. When ethanol treated with potassium permanganate, we will get carboxylic acid. This reaction is called as oxidation reaction. Name of the acid, ethanoic acid. When ethanoic acid treated with sodium hydroxide, we will get sodium acetate. This reaction is called as neutralization reaction. When sodium acetate treated with mixture of sodium hydroxide and calcium oxide, they collectively call it as soda lime. occur in decarboxylation, we will get methane. So this reaction is called as decarboxylation reaction. When methane treated with chlorine in presence of light, we will get chloromethane. Again, this reaction called as photolytic substitution reaction. When chloromethane treated with sodium in presence of ether, we will get ethane. This reaction is called as Wood's reaction. Next question, starting with compound propane. When propane treated with chlorine in presence of light, we will get compound A. When compound A treated with alcoholic KOH, we will get compound B. Compound B treated with ozone, mixture of water and zinc, we will get two compound C and compound D. Compound D is molecular mass 46 atomic mass unit. This compound D treated with reducing agent lithium aluminum hydride, we will get compound E. Compound E treated with phosphorus pentachloride, we will get compound F. Compound F treated with sodium and ether, we will get compound G. Compound G again treated with chlorine in presence of light, we will get compound H. H again treated with alcoholic KOH, we get compound I. We should write geometrical isomerism of compound I. First one, when propane treated with chlorine in presence of light, we will get chloropropane. 2-chloropropane. This 2-chloropropane treated with alcoholic KOH occur in elimination, we will get propene. Name of the elimination, beta elimination. When propene treated with mixture of ozone, water and zinc, we will get methanol, HCHO, and ethanol, molecular mass 46 atomic mass unit. When ethanol treated with lithium aluminum hydride, it acts as a reducing agent. Ethanol reduced to ethanol. When ethanol treated with phosphorus pentachloride, we will get chloroethane. This chloroethane treated with sodium in presence of ether, we will get butane. When butane treated with chlorine in presence of light, we will get chlorobutane, 2-chlorobutane. These 2-chlorobutane involved in beta elimination, we will get 2-butene. For 2-butene, we can write cis and trans isomerism. What is a cis isomerism? Similar group lie on same side. Trans isomerism, similar group lie on opposite side. Cis trans. I will repeat again. When propane treated with chlorine in presence of light, we will get 2-chloropropane. This reaction is called as photolytic substitution reaction. When chloropropane treated with alcoholic KOH, you will get propene. This reaction is called as beta elimination. When propene treated with mixture of ozone, water and zinc, this reaction is called as ozonolysis. During ozonolysis, we will get mixture of ethanol and methanol. When ethanol treated with lithium aluminum hydride, we will get ethanol. This reaction is called as reduction reaction. When ethanol treated with phosphorus pentachloride, we will get chloroethane. This chloroethane treated with mixture of sodium and ether, we will get butane. This reaction is called as Woods reaction. When butane again treated with the chlorine and in presence of light, you will get chlorobutane, 2-chloropbutane. This reaction is called as photolytic substitution reaction. This 2-chloropbutane treated with alcoholic KOH occur in beta elimination, we will get 2-butene. This 2-butene we can write geometrical isomerism. When similar group lie on same side, they called as cis isomerism. If similar group lie on opposite side, they called as trans isomerism. Next question started with ethene. What is the structure of ethene? CH2 double bond CH2 treated with bromine in presence of carbon tetrachloride, we will get compound A. When compound A treated with alcoholic potassium hydroxide, we will get compound B. When compound B treated with soda amide NaNH2, we will get compound C. Compound C passed over a red hot iron tube. We will get compound D. Compound D treated with concentrated sulfuric acid, mixture of nitric acid and sulfuric acid. Chlorine in presence of light. Excess of chlorine in presence of anhydrous aluminum chloride in dark condition. Treated with excess of chlorine in presence of light and heat. Treated with chloromethane CH3Cl and in presence of anhydrous aluminum chloride. Then treated with acetyl chloride CH3COCl and anhydrous aluminum chloride. Then burn in presence of air. Started from ethene treated with bromine in presence of carbon tetrachloride, we will get 1,2 dibromoethane. So compound A is 1,2 dibromoethane. This 1,2 dibromoethane treated with alcoholic KOH, we will get CH2 double bond CHBr. bromoethene occur in elimination. This bromoethene treated with mixture of sodium and ammonia, they are considered as soda amide. We will get ethane. This ethane passed over red hot iron tube occur in cyclization. We will get benzene. So compound D is benzene. When benzene treated with concentrated sulfuric acid, this reaction is called as sulfonation reaction. We will get benzene sulfonic acid. When benzene treated with mixture of concentrated nitric acid and sulfuric acid occur in nitration, we will get nitrobenzene. When benzene treated with chlorine in presence of Lewis acid FeCl3 occur in chlorination, we will get chlorobenzene. When benzene treated with excess of chlorine in presence of anhydrous aluminum chloride and dark condition, we will get hexachlorobenzene 1, 2, 3, 4, 5, 6 hexachlorobenzene. Then benzene treated with excess of chlorine in presence of light and heat occurring substitution reaction, we will get BHC, benzene hexachloride. So this compound through addition reaction. Next, benzene treated with chloromethane in presence of anhydrous aluminum chloride, we will get toluene. Benzene treated with acetyl chloride in presence of anhydrous aluminum chloride, we will get acetophenone. When benzene ignited in presence of air, we will get carbon dioxide and water. Benzene contains 6 carbon atoms, so we will get 6 CO2, 6 hydrogen atom, we will get 3 H2O. Total number of oxygen 6 into 2 12, 12 plus 3 15. So number of oxygen 15 by 2 O2. I will repeat again. When ethene treated with bromine in presence of CCl4, this reaction is called as bromination reaction. Addition reaction, we will get 1, 2 dibromoethane. This 1, 2 dibromoethane treated with alcoholic KOH, we will get bromoethene. This reaction is called as elimination reaction. Then treated with soda lime, again occur in elimination, we will get ethane. This ethane passed over red hot iron tube, we will get benzene. Benzene treated with concentrated sulfuric acid, we will get benzene sulfonic acid. Then benzene treated with mixture of concentrated nitric acid and sulfuric acid, we will get nitrobenzene. Then benzene treated with chlorine in presence of ferric chloride, we will get chlorobenzene. This reaction is called as chlorination. Benzene treated with excess of chlorine in presence of anhydrous aluminum chloride under dark condition, we will get hexachlorobenzene. When benzene treated with excess of chlorine in presence of light and heat, we will get benzene hexachloride, pesticide, BHC. When benzene treated with chloromethane in presence of anhydrous aluminum chloride, we will get toluene. Name of this reaction, Friedel-Crafts alkylation. When benzene treated with acetyl chloride in presence of anhydrous aluminum chloride, we will get acetophenone. This reaction is called as Friedel-Crafts acylation. Finally, when benzene ignited in presence of air, we will get carbon dioxide, water and heat. This reaction is called as combustion reaction. Next question started with 2-bromopropane. What is the structure of 2-bromopropane? CH3, CHBr, CH3. When 2-bromo treated with alcoholic KOH, we will get compound A. Compound A treated with hydrogen bromide in presence of peroxide, we will get compound B. Compound B treated with sodium in presence of ether, we will get compound C. Compound C treated with anhydrous aluminum chloride and HCl, we will get compound D. When compound C treated with chlorine in presence of light, we will get compound E. Again compound E involved in elimination treated with alcoholic KOH, we will get compound F. We should write geometrical isomerism of compound F. Two bromopropane treated with alcoholic KOH occur in elimination, we will get propene. What is the structure of propene? CH3, CH double bond, CH2. So A is propene. When propene treated with hydrogen bromide in presence of peroxide, name of this reaction anti-Markovnikov rule, we will get 1-bromopropane. CH3, CH2, CH2Br. This 1-bromopropane treated with sodium and ether, we will get hexane. CH3, CH2, 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 CH3. Hexane treated with anhydrous aluminum chloride and hydrochloric acid occur in isomerization, we will get CH3, CH, CH3, CH2, CH2, CH3. Name of the compound 2-methylpentane. Chain isomerism of hexane. This reaction is called as isomerization. When hexane again treated with chlorine in presence of light, we will get chlorohexane. This chlorohexane again treated with alcoholic KOH occur in elimination, we will get 2-hexene. CH3, CH double bond, CH, CH2, CH2, CH3. These hexene have geometrical isomerism, cis and trans isomerism. What is a cis isomerism? A similar group lie on same side. The another side, 1, 2, 3, 4 carbon is there. Number of hydrogen 3, 5, 7, 8, C4H8. This isomerism is called as cis isomerism because similar atoms, hydrogen, hydrogen located in same side. So this isomerism is called as cis isomerism. Next one is trans isomerism. Here similar group, similar atom located in opposite side. So this isomerism is called as trans isomerism. I will repeat again. 2-bromopropane treated with alcoholic KOH. This reaction is called as beta elimination. We will get propene. Propene treated with HBr in presence of peroxide. This reaction is called as anti-Markovnikov rule. We will get 1-bromopropane. This 1-bromopropane treated with sodium in presence of ether, we will get hexane. This reaction is called as Woods reaction. When hexane treated with aluminum chloride and HCl, we will get 2-methylpentane. This reaction is called as isomerization. When hexane treated with chlorine in presence of light, we will get 2-chlorohexane. This reaction is called as photolytic substitution reaction. This 2-chlorohexane treated with alcoholic KOH occur in elimination, we will get 2-hexene. This reaction is called as beta elimination. 2-hexene can have geometrical isomerism. Similar atom located in same site, which is called as cis isomerism. Similar atom located in opposite side, which is called as trans isomerism. Next is orientation in aromatic electrophilic substitution reaction. This orientation depends on the nature of the substitution. If benzene ring bonded with electron donating groups or activating groups, increase the electron density in ortho and para position. Incoming electrophile oriented towards ortho and para position. If benzene bonded with deactivating group, which decrease the electron density in ortho and para position, incoming electrophile oriented towards meta position. So this orientation purely depends on nature of the substitution. Orientation in aromatic electrophilic substitution reaction. This orientation can be classified into two types. Ortho-para directing groups. Another one is meta directing groups. These ortho-para directing groups called as activating groups. They are activated in the benzene ring. Meta directing group called as deactivating groups. An example of ortho-para directing groups: hydroxide, NH2, all the alkyl group R, OR, NHCOCH3, halogens, chlorine, bromine, iodine, even fluorine also, SH. These groups increase the electron density in ortho and para position, so they are called as activating groups or else ortho-para orienting groups. Meta directing groups decrease the electron density ortho and para position, so they are called as meta directing groups. Example: cyano, CHO, aldehyde group, carboxyl group, COOH, ester, COOR, SO3H. These groups decrease the electron density in ortho and para position, so incoming electropile oriented towards meta position. This ortho-para orientation I will explain through resonant structure of phenol. Benzene has alternative pi bond. The functional group is hydroxide, alcohol. This oxygen has two lone pair of electrons. This lone pair make double bond with carbon. This electron stay on ortho position. So we can write like this. Now electron density increase in ortho position. To form oxonium ion. Next, this electron come and stay on para position. Now two parallel electron in the benzene ring, one electron on the para position, double bond O. Then this electron shifted towards neighbor carbon atom. This electron will stay on again ortho position. Finally, this electron shifted towards neighbor carbon atom. Then this electron moving towards oxonium ion. This resonant structure of phenol explain increase the electron density in ortho and para position. So incoming electropile oriented towards ortho and para position. So they are called as ortho and para directing groups. Next is resonant structure of nitrobenzene. Nitrobenzene deactivated in the benzene ring. It withdraw electron from benzene ring. So decrease the electron density in ortho and para position. Incoming electropile moving towards meta position. So nitro group called as meta directing group. Benzene bonded with nitro group. This compound is called as nitrobenzene. Oxygen highly electronegative than nitrogen. This electron shifted towards oxygen. Now this nitrogen take the electron from the benzene ring. Now carbocation created on ortho position. This carbonium ion will be satisfied. This carbonium ion compensated with neighbor pi electron. Now carbocation created on para position. Now this electron shifted towards carbocation. Again carbocation created on another ortho position. Then again resonance will take place. So conclusion, electron density decreases in ortho and para position, incoming electropile oriented towards meta position. So these deactivating group called as meta directing groups. Next conversion, benzene should be converted into 4-nitrotoluene, another one is 3-nitrotoluene. We all are know methyl group will be ortho-para directing group. When benzene converted into 4-nitrotoluene, first we should do Friedel-Crafts alkylation, methylation. Benzene should be converted into toluene. Benzene treated with chloromethane in presence of anhydrous aluminum chloride. Benzene converted into toluene. The nature of methyl group, ortho-para orienting group, it supplies the electron towards benzene ring. So increase the electron density, ortho and para position. Now incoming electropile oriented towards ortho and para position. Now toluene involved in nitration, mixture of concentrated nitric acid and sulfuric acid. They produce a nitronium ion. Now nitration takes place in both ortho and para position. We will get ortho nitrotoluene as well as para nitrotoluene. This para nitrotoluene will be major, ortho nitrotoluene will be minor product. Next conversion, benzene to 3-nitrotoluene. Nitro group is meta directing group. So benzene first involved in nitration. Mixture of concentrated nitric acid and concentrated sulfuric acid. They collectively called as nitrating mixture. They produce nitronium ion. Now benzene converted into nitrobenzene. This nitrobenzene, nitro group, meta directing group, when treated with chloromethane in presence of anhydrous aluminum chloride, alkylation takes place in meta position. We will get 3-nitrotoluene. Next conversion, starting with propene. Structure of propene: CH3, CH double bond CH2, treated with hydrogen bromide in presence of peroxide. The product considered as A. When A treated with sodium in presence of ether, we will get B. B treated with vanadium pentoxide at 773 Kelvin, 5 to 15 atm pressure, we will get C. When C treated with bromine in presence of FeBr3, we will get D. Same C treated with concentrated sulfuric acid, we will get E. When D treated with chloromethane in presence of anhydrous aluminum chloride, we will get F. When E treated with chlorine in presence of FeCl3, we will get G. Propene treated with HBr in presence of peroxide, we will get 1-bromopropane. This reaction is called as anti-Markovnikov rule. CH3, CH2, CH2, Br. When 1 bromo treated with sodium and ether, we will get hexane. So B is hexane. Molecular formula, structural formula of hexane, CH3, CH2, 4 times CH3. This reaction is called as Woods reaction. When hexane treated with vanadium pentoxide at 773 Kelvin, 5 to 15 atm pressure, occur in cyclization, we will get benzene. So C is benzene. When benzene treated with Br in presence of FeBr3, we will get bromobenzene. Bromine is orthopara orienting. When treated with chloromethane in presence of anhydrous aluminum chloride, we will get 2 isomeric product, orthobromotoluene as well as para-bromotoluene. Para will be major due to less steric hindrance. When benzene treated with concentrated sulfuric acid, we will get benzene sulfonic acid. This benzene sulfonic acid meta-directing group, when treated with chlorine in presence of FeCl3, we will get metachlorosulfonic acid or 3-chlorosulfonic acid. I will repeat again. When propene treated with HBr in presence of peroxide, we will get 1-bromopropane. Name of this reaction, anti-Markovnikov rule. When 1-bromo treated with mixture of sodium and ether, we will get N-hexane. This reaction is called as Woods reaction. When N-hexane treated with vanadium pentoxide in presence of 773 Kelvin, 5 to 15 atm pressure, we will get benzene. This reaction is called as aromatization. When benzene treated with bromine in presence of FeBr3, ferric bromide, we will get bromobenzene. Electrophilic substitution reaction. Nature of bromine is orthopara orienting group. So methylation takes place in both ortho as well as para position. Name of the compound, orthobromotoluene and para-bromotoluene. Here para is major. Same benzene treated with concentrated sulfuric acid, we will get benzene sulfonic acid. This SO3H group, meta-directing group. So chlorination takes place in meta position. Name of the compound, 3-chlorosulfonic acid or metachlorosulfonic acid. Metachlorobenzene sulfonic acid. Next conversion, starting from toluene. Toluene or methyl benzene treated with chlorine in presence of light, we get A treated with aqueous KOH, we get B treated with strong oxidizing agent KMNO4, we will get C treated with alkali solution sodium hydroxide, we will get D treated with soda lime NaOH and calcium oxide, we will get E. When E treated with acetyl chloride in presence of anhydrous aluminum chloride, we will get F. When toluene treated with chlorine in presence of light, chlorination takes place in aliphatic part. We will get benzyl chloride C6H5CH2Cl. This benzyl chloride treated with aqueous KOH occurring substitution, we will get benzyl alcohol. This benzyl alcohol treated with strong oxidizing agent potassium permanganate. Alcohol part oxidized into carboxylic acid, benzoic acid. Benzoic acid treated with sodium hydroxide, we will get sodium benzoate. The sodium benzoate treated with mixture of sodium hydroxide and calcium oxide occurring decarboxylation, we will get benzene. Benzene treated with acetyl chloride and anhydrous aluminum chloride, we will get acetophenone. This reaction is called as Friedel-Crafts acylation. I will repeat again. When toluene treated with chlorine in presence of light, halogenation takes place in aliphatic part, we will get benzyl chloride. Benzyl chloride treated with aqueous KOH occurring substitution, we will get benzyl alcohol or phenyl methanol. This benzyl alcohol treated with acidified KMNO4, we will get oxidized into benzoic acid. This reaction is called as oxidation reaction. This benzoic acid treated with sodium hydroxide, we will get sodium benzoate. This reaction is called as neutralization reaction. Sodium benzoate treated with mixture of sodium hydroxide and calcium oxide, they collectively called as soda lime. Occurring decarboxylation, we will get benzene. This benzene treated with acetyl chloride in presence of anhydrous aluminum chloride, we get acetophenone. This reaction is called as Friedel-Crafts acylation.